Okay, now we're going to continue to finish the review packet. I want everybody to look at page 7, number 47. So now you have to remember how to write the slope-intercept form of an equation given 2 points. Well, whenever you're given 2 points, automatically find the slope. So we find the slope by finding the change in y over the change in x. So this is -3/7. Okay, once we know the slope, we now have a point and a slope. So we're going to use the point-slope form. And let me just double check. This is -5 minus -2 is +2, -3. 3, okay, I wrote that wrong. I thought something was wrong. So this becomes 3 minus 4. This is -3 over -1, which is 3. So m equals 3. And I'll use this point for -2. So now, the point-slope form is y minus y sub 1 equals m times x minus x sub 1. So now I substitute. This is x, this is y. So y minus -2 equals 3 times x minus 4. So this becomes y plus 2 equals 3x minus 12, y equals 3x minus 14, and that is my slope-intercept form. Okay, now let's look at number 51. 51 says, it goes through the point 3, 0, and it's perpendicular to the line y equals -x. Well, the first thing you do is you find the slope of this line. This slope is -1. The perpendicular slope would be the opposite reciprocal. Well, 1 over 1 is the same as 1 over 1, so all we're going to change is the sign. So the perpendicular slope would have a slope of 1. And it's going to go through this point. So again, I use point-slope form. Y minus 0, don't have to write, equals 1 times x minus 3. So y equals x minus 3. So that is perpendicular to the line y equals -x, but it goes through that point. Okay, so now let's pick one that is parallel. And that would be, let's say, number 49. So let's do 49. 49 says it goes through this point, and it's parallel to this equation. So if it's parallel, that just means I have to use a slope of -7/5. I can ignore that now. I say y minus -5 equals -7/5 times x minus 5. And this becomes y plus 5 equals -7/5 x plus 7, because that becomes 35/7. And so I get y equals -7/5 x plus 2 when I subtract 5 from both sides. Okay. So now, I don't think we need to review foiling and adding polynomials, so let's look at, it's actually the second page 1 in the packet, and we are going to sketch exponential functions. So, number 1 says y equals 1/2 times 4 to the x. Okay, so what we do for this is we set up a table. We choose -2, -1, 0, 1, 2. 4 to the x is 4 to the -2. So 4 squared is 16. I make it 1 over 16. 1 over 16 times 1/2 is 1/32. 4 to the -1 equals 1/4. 1/4 times 1/2 is 1/8. 4 to the 0 is 1. 1 times a half is a half. 4 to the first is 4. Half of 4 is 2. 4 squared is 16. Half of 16 is 8. So now, I'm just going to sketch this here. -2, very close to 0. -1, also very close. You really can't tell. At 0, I'm at a half. At 1, I'm at 2. And then at 2, I'm all the way up at 8. Remember, this gets very close to the y-axis, but it never actually hits. Okay? Now, let's do number 7. Okay. Number 7, we're working with exponents. 2a times a to the -2 b cubed. This whole thing raised to the -1 all over 2ab squared raised to the -1. So one way to do this is to fake distribute the -1 to every factor. So before I actually do that, a times a to the -2 becomes a to the -1, and I can cross that out. So this becomes 2 to the -1, a to the first, because -1 times -1 is 1, b to the -3, all over 2 to the -1, a to the -1, b to the -2. Now 2 to the -1 over 2 to the -1 just becomes 1, so I cross that out. A to the first minus -1 becomes a squared in the numerator. B to the -3 minus -2 becomes b to the -1. But I can't stop there because it's not simplified if there's a negative exponent. So then I have to move b to the -1 in the denominator, and that becomes a squared over b.